Yes, let's start. Okay, now we are working on the question on my screen. So feel free, to provide your answers. So I will, analyze each question based on your response. Do we have more answers? Okay, great. I think we almost got everyone. We got 12 out of 13. Okay, share the results with you. So we'll, quickly, analyze. The first one will produce hydrogen gas. Second one, hydrogen gas. Actually, it's not even reacting with the sodium hydroxide. It just reacts with the water, right? Next one is ammonia gas. Makes sense, right? The last one will have a reaction of carbonate and water, but no gas evolved, right? Let me know if you have any question, okay? I probably cannot fully monitor the chat box. So if you can, talk, that would be the best, okay? Yeah, I think another similar question. I probably need to log into my Discord server to update, the late students. I really apologize for this. Oh, thank you. Someone helped me. Great. Thank you. Okay. We need a few more answers. By the way, do you know what the gas will be evolved in option A? Yeah, you guys did a great job. Most of you got it correct. So in A, it would be nitrogen gas. Think about it's a redox reaction, right? The oxidation number of nitrogen in ammonia is -3. In nitrite is +3. So there is a perfect, disproportionation, right? Produce nitrogen gas. So this is an easy way to produce some nitrogen gas in the chemistry lab. And then BC already, talk about this. The last one will have a reaction, but it's Br2. As you know, Br2 is a liquid and is also slightly soluble in water, so it's not a gas. Let me know if you have further questions, okay? And then next one. It seems like this question is a little bit confusing, right? Okay, great. So then let's end here. So share the results. Most of students got it correctly. It's D. D is the least soluble with the smallest KSP. Actually, A, silver fluoride, is the most soluble and actually is the only soluble one out of these four, right? So this greatly demonstrates the difference of fluorides with the other halides, right? So when the other halides are precipitate, fluorides is soluble. When the other halides are soluble, the fluoride is precipitate. Do you know which kind of cation I'm talking about? Fluoride is a precipitate, but the other halides are soluble. So I think you can think about like calcium 2+. Yeah, I saw there's some answer in the chat box. Like, strontium, like barium. So basically, it's a 2A group, right? So this is a very great, comparison between the fluorides and the other halides. Let me know if you have further questions, okay? Let's move on. Let me see. This one not bad, so let's try it. So I probably will skip some of the questions. It seems like I made a bad question. This is not very good. It's fine. We're just here for practice. Yeah, this is not a good question. Okay. First, I need to remind the student who chose A, because copper 1 chloride is a white precipitate. So it's commonly used in the iodometry analysis for copper 2 plus, right? Copper 2 plus can react with iodide to produce copper 1 iodide, which is a white precipitate, and I2. So here, similarly, if the copper 1 iodide, the precipitate, we have reason to believe the copper 1 chloride is also a precipitate, right? Make sense to you? And actually, you can also connect this with silver chloride, because copper 1 plus and silver 1 plus are quite similar. Copper and silver, they are in the same group. So A definitely is not correct. So the reason why I say it's not a good question is because both B and D are soluble. Barium hydroxide is a soluble strong base, right? But it's not very soluble. So compared to B, B is supposed to have the highest solubility if you check the value. But I don't think you need to really figure out B or D, which one has a higher solubility. So this is not a very good question. But at least we shouldn't choose A or C, because we know those two are precipitates. This is not bad. Let's have a look. It's getting a little bit harder, actually. So diversity of your answers is also getting bigger. Okay, I think we got most of the answers. Oh, I want to remind you, most of those questions I put here are based on the existed local or national power 1. So which means either is a revision or is an extension, right? Okay. You guys can see your results, right? Yes? When I share the results with you?
Yeah.
Oh, great. Thank you. So the correct answer is D. D is the least soluble in acetic acid. First, I want to briefly talk about if you have something like this reacting with acetic acid, if we need to write down the net ionic equation, it's supposed to be something like this, right? So the K of this reaction should be KSP divided by Ka of the acetic acid to the power of 2. Do you agree with me about this? Yeah, if I didn't get any question, I'm assuming you guys all agree with this, right? So which means a smaller KSP will make this reaction non-spontaneous, more non-spontaneous, right? So the harder the solubility of the sulfide, and then the harder reaction can go to the right side. So actually, we are going to find which one has the smallest KSP. So actually, this one is related to the hard, soft acid base theory. What does it mean? Sulfide is a soft base. And then out of all of those cations, Ca2 plus, Mn2 plus, zinc 2 plus, Cd2 plus, this one is the softest. It has the perfect match with the sulfide. Why CD2 plus is the softest? What does it mean, soft? Which means it has a more negative charge, a larger size, a relatively easy to be affected electron cloud, right? So if you compare those three, let's say, yeah, those three, they are in the same period, right? But going down is getting softer because there are more electrons, especially 3D electron are softer. And the CD2 plus, the cadmium, is in the 5th period, right? So it had one more layer of electron, so it's softer. So the CD2 plus is the softest. Yeah, definitely cadmium is softer than the calcium 2 plus. Calcium 2 plus is supposed to be the hardest here. So if you need to figure out which is the most likely to dissolve in 1 mole of acetic acid, you should choose A. Does this make sense to you? You can check the periodic table, okay, to keep the locations of each element in your mind.
Wait, so the answer is A or B?
The answer here is D. I mean, if we change this into most likely, and then the answer is A.
Okay. Okay.
Makes sense. Great. Yeah, this is not a bad one. Let's have a look. This is very interesting. Okay, we'll end the poll in a few seconds. Okay, let's have a look. So the correct answer is B, copper 2 hydroxide, because it can react with the ammonia to make a deep blue complex, right? You can easily find the phenomena from YouTube, right? Just search, copper sulfate plus ammonia, and then you will see a great video, very beautiful, deep blue. A lot of you choose A, but actually A is not soluble in ammonia. There is no complex like this. There's no complex like this. Probably it's because aluminum is too hard, because it's a main group element with a +3, positive charge, so which means it's very small in size and higher charge, so it's very hard. And ammonia is kind of a mediocre, base from the perspective soft and hard, right? Because nitrogen is not very, very, electronegative, but it's also kind of electronegative, so it's kind of mediocre. So a combination of these two probably not so good. This is just my guess. I'm not very sure about why there is no complex in between aluminum 3 plus with ammonia. But we are very sure, aluminum hydroxide will not dissolve in the ammonia. So which means if you have aluminum 3 plus, you add some concentrated ammonia, what you will get? Think about this question. Yeah, I got a question. The bigger the atomic radius, the softer the element. Yes. Yes, it's correct. Yeah, I think you will agree there will be a precipitate of aluminum hydroxide plus ammonia, right? It's acid-base neutralization. I didn't say calcium is low. I don't think cadmium has a smaller atomic radius. I think calcium should have a smaller, radius. You guys can double check. Okay, you have data. How about calcium? I'm not talking about the atom. Do you have the value for the cations? Okay, well, this is interesting. Do you guys have any idea about this? Yeah, I agree with you. I think it's more likely the effective nuclear charge. So the conclusion definitely is the CD2 plus is softer. Yeah, probably, I use a bad wording. So it's not necessary to be related to the absolutely size, right? It's more likely whether the electron cloud is easy to be affected or not. Thanks for raising this point. Thank you. Let me see. I think we can skip this question. This is not a bad one. Let's have a try. Okay. Okay, we got most of the answers here. Okay, the correct answer is D. Chromate is a yellow anion. You probably know the dichromate is orange, right? So there is a equilibrium between the chromate and the dichromate. I will leave you a question for you to think about. What will be the net ionic equation to finish this conversion, right? It's a non-redox reaction. So a lot of you choose, the diamine silver plus. Actually, this one is colorless. You can also search in YouTube to find the video. Silver nitrate, add ammonia. First, you will see some brown precipitates. And then if you keep adding the ammonia, the brown precipitate will dissolve. So what is happening? What is the brown precipitate? Do you have a good guess? Any idea about the brown precipitate? Actually, it's because first, it produced the silver 1 hydroxide. This is supposed to be a white precipitate, but it's unstable, so it will decompose into silver 1 oxide. This is a brown or black precipitate. And then if you keep adding the ammonia, so this one will go back to the silver hydroxide and finally change into the diamine silver 1 plus, which is a colorless, complex ion. So why this is colorless? Think about why zinc 2 plus is colorless. This is a standard AP question, right? It's because zinc 2 plus 3D is full field, right? The full field D orbitals will have no chance to do a DD transition. So according to the crystal ligand theory, we know the D orbitals will be split into two groups in an octahedral ligand environment, right? But if all of those 5D orbitals are full filled, so there's no way for the electron from the lower energy level to jump to the higher energy level. So here, silver plus is the same as zinc 2 plus because silver plus is also full filled. So no matter what is the ligand, the complex made by silver plus, zinc 2 plus, cadmium 2 plus, mercury 2 plus will all be colorless. Make sense? Okay, let me see. This is not good. Maybe we can skip this one as well. I will try to leave those kind of error analysis questions in the end because they are pretty annoying, right? We really need to calm down and analyze it step by step. How about this one? Not bad, but easy to make mistakes. You are all very experienced, right? None of you really made the mistake. Yeah, I should say most of you didn't make the mistake. Okay. Some of you are still thinking. Okay. So this question is related to the colligative properties, right? So the correct answer is B because it's a non-electrolyte. So 0.1 molality is 0.1 molality of particles. All of A, C, and D, they are electrolytes, which means they will dissociate into more ions, right? Colligative properties are just based on the number of particles in the solution, right? It's not related to what kind of particles they are. So I think you understand, the wave pressure, so I don't need to explain that. This question is from the local 2020, so it's also related to the error analysis. So we will leave it to the end if we have time. This is also a question based on 1 year of National Power 1. Question is not hard, but actually the correct percent is pretty low, right? A lot of you choose C because you probably think silver chloride is a white precipitate, and we will know the endpoint when there is no more white precipitate produced. But it's not practical because how can you tell, there's no more white precipitate, right? So you still need to use the indicator. What is the indicator? Is the chromate. The chromate combined with the silver plus to produce a reddish brown precipitate. So when the white precipitate change into a little bit, reddish brown, and then we can say endpoint is here, right? So only A doesn't need to use the indicator because the permanganate itself is purple. It has a very strong color. So this kind of color will either disappear or appear to show the endpoint. Make sense? Okay. One student choose D. This one is an acid-base neutralization, so which means you may need to use either like phenolphthalein, orange, methyl orange, methyl red, right? This question. Not too hard, right? I think you probably remember the original question is a copper nickel alloy, right? So I slightly revise it into copper zinc alloy. And the nickel one is harder because nickel is not a very common, metal. Okay, so I'm assuming, the student who didn't choose the answer yet probably didn't do this national question before. So I will end here. No problem, right? Yeah, iodometry, as we discussed. Let me see. Yeah, this is also a good question. So descriptive chemistry is just for you to know more stuff. But some of them can be, explained. Some of them are just some trivial stuff you need to know. If you don't know, you cannot figure it out. It's not like the other parts. So this is why it's harder to prepare. And especially in the AP chemistry curriculum, the descriptive chemistry part was deleted, about 10 years ago before. So if you go back to work on the AP chemistry exam, I remember back to 2004, 5, maybe a little bit later, there are a one big question asks you to write down a lot of net ionic equations, which is quite similar to the question in National Part 2. So I think you probably remember this question is based on original National Part 1 question. The previous question is iron 3 chloride. Oh, sorry, I should delete the non-white, is just a white solid. So sorry about this. Probably it misled you. So the correct answer is supposed to be B. First, there is a white precipitate produced, which is iron 2 hydroxide, and then it will quickly, turn into green, and then finally, after a long time, it will be reddish, brown, which is the iron 3 hydroxide. So I believe, the green stuff is something in between, or part of the iron 2 hydroxide is oxidized. Make sense? Which means the +2 iron 2 plus is relatively unstable, especially in the basic condition. So you can also search this, video in YouTube by yourself. Okay.
Wait,
Go
what
ahead.
did you mean by like precipitation of a white solid first? So like, is there another white solid that precipitates first in the first question?
Yeah, I think I made some, bad wording. So what I meant to say is there will be a white solid produced first, and then this white solid, turn into a colored precipitate later. Does this make sense?
Wait, so what is the white solid? Is that iron 2 hydroxide?
Yes, yes, this is the white one. And then
okay.
the reddish brown is iron 3 hydroxide. Okay, this one not bad. Let's test. You guys know what is the phenolate, right? Is the conjugate base of phenol. Not bad. Okay. So the correct answer is A. First, compared to B, there's comparing A and B, there's no reason to choose B. Okay, because sodium carbonate definitely is more basic than sodium bicarbonate. Why? Think about the conjugate acid, right? We know the stronger the conjugate acid is, the less basic, right? So which means here, the conjugate acid is corresponding to the pKa2 of carbonic acid, right? Here is the pKa1. So pKa1 should be, or Ka1 should be greater than Ka2, which means the first one will have a greater degree of hydrolysis, right? So I think the key point is the comparison between A and C, although only 2 students chose C. So which means we may need to analyze the pKa, or the acidity of the phenol, its ranking, right? What is the ranking of the phenol? Actually, phenol has a pKa of 10, so which means it's smaller than the pKa1 of the carbonic acid, which is around 7, and it's greater than, I'm not talking about the pKa, I should say the Ka, or the acidity, which is greater than the pKa2, which is around 11, right? So I will have a similar, which is slightly harder organic question later to prepare for you to test whether you really have a great understanding about this topic or not. Let me know if you still have any question. This is too time consuming. Let's skip it. This is too stupid. This is not too bad. Let's try it. Okay, yeah, I pretty much got all of the answers. So the correct answer is C. Obviously, this is the equation for the real gases, right? So for the real gas, we know the reason why we have another part to be added to the pressure is because the real pressure is smaller than the ideal pressure. Why? Pressure is produced by the collision of the gas molecules to the container wall, right? So in our ideal gas model, we assume there's no interaction, there's no attraction among the gas molecules. But actually, it's not true, especially for those molecules with a relatively larger intermolecular forces. So they will attract to each other, which will reduce the frequency of the gas molecule to collide with the wall of the container. So I think ammonia is the case here. It has hydrogen bond, right? Although here it might not be hydrogen bond because in the gas system, the distance probably is too big to make a hydrogen bond, but still it's polar. It has a relative, larger intermolecular forces. So this is why it will disobey the ideal gas law the most. Make sense? A good one. I think after our discussion, this one will be easy. Okay, all of you choose the answer. The correct answer is B, right? We just finished discussion. Option D is deep blue, right? The complex between the copper 2 plus with the ammonia. So we know the hydrated copper ion, no matter how many water molecules, is blue. It's just a regular blue. But the complex with the ammonia is deep blue. This probably can be explained by using the ligand, the crystal ligand theory, right? Crystal field theory, I'm so sorry. So because different ligands will have a different splitting energy, which make the energy gap between these two, d orbitals different, and then it will be responding to a different color, right? So we talk about this. This one is supposed to be colorless, right? It's copper 1 plus. So can you think about what will be the reaction in the second step? Can you take 30 seconds or 1 minute to write down the Nader ionic equation in the second step? Yeah, just try it. Don't be lazy. Write it down. I'll be right back. So I'm assuming you guys are done. So what is the oxidizing agent in the second step? Because obviously is the copper 1 plus is oxidized into copper 2 plus, right? So what might be a reasonable oxidizing agent in the second step? No response? I'm talking about, you know, the colorless solution changed into blue. Is O2 a reasonable oxidizing agent? And then what is the product of the O2? So this one is oxidized. The oxidation number increased by 1. This one is decreased by 4. Obviously, the oxygen will change into a -2 oxygen, right? So we just need to figure out what is the reasonable form, either water or hydroxide, right? If you need to have water, you need to have H plus in the left side. But obviously, this is the basic condition because you have the excess amount of ammonia. So I think it's more reasonable to write down into hydroxide, right? So we'll try to balance it in this way. And then we need to add more ammonia from the left side. H, there would be 8 ammonia. So now I think, hydroxide probably is not very, it seems like not easy to be balanced. How to balance? Oh, okay. Yeah, makes sense. So in order to balance the charge, we have 4 plus in the left side. We have 8 plus in the right side. We need to have 4 hydroxide. Yeah, and then we need to add 2 water molecules. And finally, it's done. Make sense? You guys can help me check, you know, all of the atoms, including copper, ammonia, hydrogen, oxygen. I think it's balanced. It's a little bit messy. Question? Did you successfully, you know, balance the reaction or, you know, write down the reaction? Although in National Part 2, you don't need to balance the reaction, but I think it's a good practice for you. If you try to balance all of the reactions you wrote. Okay. Let's try this question. You guys know what is diamagnetic, right? Which means there is no unpaired electrons. Okay, I got 10 answers. Most of you choose D, but actually the correct answer is C. You have different ways to work on this question. First, let's think about what will be the charge of NO, right? Yeah, I saw someone raise the hands. Do you have anything to say? Okay, I will continue. If you want to say anything, you just, you know, unmute yourself and feel free to talk, okay? So the NO here is either -1 or +1, right? Because if it's just neutral, it should be paramagnetic. So if it's -1, the ion will be +4 in order to balance the charge, right? So obviously, there's no +4 ion, and there's no option of +4 here. So the NO can only be NO1 plus, which means the ion will be 2 plus. Make sense? If the ion is 3 plus, which means the NO is neutral, is a molecule. If it's a molecule, it definitely is paramagnetic because nitrogen monoxide is a molecule with a odd total electron, right? So you cannot make all of the electron paired. There must be at least one single electron. So this also explains why NO, NO2 are relatively easier to dimerize into N2O2 and N2O4, right? And the dimerization of NO2 and N2O4 is a very good demo of Le Chatelet's principle, right? Because NO2 is reddish brown, and then N2O4 is colorless. So we can observe the color change to conclude, the shift of the equilibrium. Make sense? This is a calculation. Let's skip it first. This is not hard. I try. Can you guys see, how many students answer the question already? Okay. Okay. Makes sense. Yeah, probably you understand this is not really a calculation, right? You need to know how to get the pH. Because we even sorry. Okay, the correct answer is D, because for a amphoteric species like this, the pH is supposed to be the average of pK1 and the pK2. So I have no time to derive the equation here to you guys, so check this later by yourself if you're not very sure about this, okay? I think this is a good one. Definitely is a original question you never tried before. And this is also the trend of the USNCO. There will be more questions based on, reading the pictures, the diagrams, and then interpret the new concepts behind the diagram. It's a little bit long, so take some time to read it. Oh my God. Let me put my phone into airplane mode. You guys probably use the deionized water in the chemistry lab, right? How does the deionized water, produced? Actually, through most of the deionized water are coming from the ion exchanging, kaolin or resin. So the general idea is the cations in the water will be replaced by the H+. The anion in the water will be replaced by the hydroxide, right? Okay, now stop here. So the correct answer is A. A is incorrect because the total number of cations in water will increase. Have a look. You have some +2 cations. So each of them will be replaced by 2H+, right? So the total number of cations will increase. A lot of you choose C. I didn't quite get it. So obviously, the conductivity of water will decrease because there is a neutralization reaction in the anion exchanging part, right? And water is a super weak electrolyte, so which means the conductive ions are gone, changed into water, right? Do you like this question? I think it's a good one. This one is too hard. Maybe we can try this one, a little bit long, and also a diagram-based question. Is the font big enough for you to read? The question is asking you which one is incorrect, okay? Yeah, seriously, feel free to turn your video on, right? It's very weird to just see a lot of, black box. Okay, now stop here. Most of you choose B. Do you think B is the correct answer? Or is the incorrect, statement? Yes, it is. It's incorrect. Why? Have a look at here. N and P, they are in the same line, right? They are in the same saturation line, so which means they are supposed to have the same KSP, right? So it's incorrect. Some of you choose C, some of you choose D. D probably is right. We don't know, to be honest, because we don't know the dissolution of the cadmium sulfide is exothermic or endothermic. So we are not very sure how the KSP will change with temperature, right? So we have no reason to say D is incorrect, although most of solids will dissolve more in water with a higher temperature, right? But we are not sure. We don't know the information. So the incorrect piece in option B is pretty obvious. Okay, let's move on. Let's skip this question first. Have a look at this one. Quite similar to 1 year of the national part 2, right? The potential metric titration. If you did that question before. The y-axis here, the y-axis is a negative logarithm of chloride. Are you asking about this? So is the free chloride concentration in the solution? Okay, give you a few more seconds. Okay, let's stop here. So the correct answer of the question is C. Why this one is incorrect? Have a look. 50, 0.05 will give you a endpoint of here, 25. Makes sense, right? Because 25 milliliter multiplied by 0.1 equals to 50 multiplied by 0.05. And here is 0.04 multiplied by 50 equals to what is the volume times the concentration, right? So as you can see, the concentration, the volume should be 20 milliliter, so which means it's supposed to be here, right? The new endpoint is supposed to be here. Make sense? Some of you choose D. Actually, D is correct. Because if you change into bromide, we know silver bromide have a smaller KSP, which means at the end point or the equivalence point, the free bromide concentration will be lower. So it will jump up, but the volume will still be the same, right? Make sense? Do you like this question? I think it's a pretty good one. There is a tricky question. But this is the question I like the most. Enjoy. Okay. So the correct answer indeed is C. As a diprotic acid, the pK1 is very small. I think it's negative, which means the first step of dissociation of sulfuric acid is complete. So this is why you do not have the first endpoint here. You do not have a pH window at the first equivalence point. So there's only one equivalence point, right? If I further ask you, what is the curve for phosphoric acid? Can you vote again? So obviously it's either A or B, right? But it's pretty weird, right? Phosphoric acid is a triprotic acid. We are supposed to have a 3 endpoint, although it's not done yet. It's not done yet. But actually, if you check the full titration curve of phosphoric acid, there is no third endpoint. I think probably this question is a little bit too much to ask, but I still find, most of you guys choose the correct answer. So may I ask anyone, to briefly talk about the reason why you choose this answer? Ways, would you mind to briefly talk about your justification? Yeah, if you can unmute yourself.
I mean, how I thought of it is a bit weird and hard to explain.
Mm-hmm.
So I don't know if I'm the best to explain it.
Okay. I think the best way definitely is we know all of the pKs, and then we can use the half equivalence point to conclude which one is which, right? But right now, obviously, we do not have the data. So I think for A and B, it's not easy to distinguish, right? But if you have a certain sense of, how strong, the phosphoric acid is, probably you can choose A. The correct answer is A. Let me know if you have any other, good explanations, which is convincing. Wait a second. Why the pose? Okay. You guys can check the pKa's by yourself and double check, why A is correct. Okay. But similar to Ways, I do not have a very convincing, idea to share with you why A is the correct answer, because I know the pK of phosphoric acid. But as I mentioned, there's no third point for phosphoric acid. Do you guys know what is the reason why there's no third point? Do you remember in 1 year of National Part 3, there is a titration lab. It's an unknown, acid titrated by sodium hydroxide by using a universal indicator to draw a titration curve to figure out whether it's monoprotic, diprotic, or triprotic, right? Because the universal indicator can only show color change, from pH around 3 to pH 10, 11, something like that. So actually, even there is a third point. If the third point's pH is higher than pH 10, you cannot tell. But even if you use a pH meter, you still cannot find the third point because the pKa3 of phosphoric acid is too small, which means there's no significant pH increasement around the third point. Check the titration curve by yourself, okay? This is a little bit tricky question, but I believe you guys will not be tricked by me. So I have 3 major parts today for you. The first part is descriptive. So we finish most of the questions I have. The second part is what we are working right now is, equilibrium, thermokinetics, and those kind of, non-calculation questions. I only chose those non-calculation questions, okay? I skipped all of the questions based on calculations. And the last part is organic chemistry, some advanced organic chemistry. I have to say your answers are a little bit surprising because obviously a lot of you are confused by the question. So this is actually one of the hard points of the national exam. So you need to have a deeper understanding. There will be more conceptual questions in the test. Oh, I should say, wait a second. I shouldn't say both, right? I should say all, because there are 3 reactions, right? Yeah. Yeah. Okay. So the correct answer is B, because Arrhenius equation, right? Higher temperature, faster reaction rate. So the rate is not related to whether the reaction is exothermic or endothermic, right? This is a little bit confusing, right? Make sense? Only the equilibrium constant is temperature dependent. The reaction rate constant is also temperature dependent, but is kind of positive, related, because according to the Arrhenius equation, so here, if you compare this equation with the Van 't Hoff equation, that one is K2 over K1, the equilibrium constant, and the EA is changed into delta HR. So delta HR can be positive, can be negative. It depends on the reaction is exo or endothermic. But for the activation energy, EA is always positive. It's either large or small, but it's always positive. So this is why if T2 is higher than T1, so K2 is always bigger than K1. So don't be confused by the question. Please keep these 3 reactions in mind. I have another tricky question for you to think. Yeah, probably I should say this is my favorite questions. Among all of the questions I shared with you today, including those I'm going to share with you. Okay, let's briefly talk about this. Surprisingly, most students choose C, unchanged. This is incorrect. The correct answer is B. So the primary products will be higher. Why? First, obviously we know the secondary free radical is more stable than the primary free radical due to the hyperconjugation, right? So at a lower temperature, you can imagine the chlorine atom will carefully compare which place is more stable and choose that place to react. At a higher temperature, the reaction is more rigorous. It's much faster. So which means the chloride will not, really choose a place. It will just, randomly select a position. And then if the temperature is higher enough, I would like to say the ratio of these two will be more proportional to the number of primary hydrogens and secondary hydrogens, which is 6/2. So there are 6 primary hydrogens, 2 secondary hydrogens. So if the temperature is high enough, the ratio of these two will be close to 3:1. Does this make sense to you? I don't think you really need to use the information from the previous question, but it's a little bit related because at least you understand. Higher temperature will result in a faster reaction rate, and then the reaction will be less selective. Make sense? Let me know if my explanation is not convincing and you have other ideas about this question. The answer is B. Okay. Share my third favorite question with you. Actually, I love most of the questions because I made most of them by myself. Can you see the poll or you are still thinking? Oh, okay, great. Sometimes probably it's stuck. Okay. How do you think? The correct answer is A. Why is A? First, all of them are magnesium, right? So which means A and D are Mg+. So for A and D, it's like the secondary ionization energy of magnesium. And for B and C is the Mg atom, so it's the first ionization energy. So first, you need to eliminate B and C because the second ionization energy is always greater than the first one, right? And then let's compare A and D. So obviously, electron in the 3p has a higher energy than 3s, which means it's easier to be ionized. So this is why the answer is A. Do you like this question? It's a good one, right? Okay. And then I think we are very close to the organic part. Thermostability doesn't mean boiling point, okay? It means how easy it will be decomposed under a certain temperature. That is the meaning of thermostability. Okay. Some of you are still thinking, but I may have to stop here. Yeah, I think most of you choose the correct answer is A, because the bond between hydrogen and those 4A group elements is getting stronger, it's getting weaker down the group, right? Because it's the 1s electron to overlap with the NP electron. Maybe I should say the nsp3 hybridized orbital, right? So the orbital is getting bigger. So the overlap is getting weaker down the group. So this is why it's easier to decompose. Make sense? Okay, a few more answers, please. By the way, is this a good pace? Is it too fast, too slow? Let me know. We can slightly, change the speed based on what you need, okay? Okay, I think all of you got the answer. The correct answer is A, because obviously the O2 here is O2 plus. How do we know? Because arsenic is in 5A group, right? So which means this one is a complex anion, right? 6 fluorides, complex with the central 5 plus arsenic. So if it's O2 plus, based on your understanding about the molecular orbital diagram of O2, in O2, there are 2 electrons in the antibonding orbital, right? So 1 less electron, which means 1 less antibonding electron, will increase the bond order and make the bond length shorter. Okay. I also like this question very much. This is a combination of an AP question with a USNCO question. Okay, a few seconds. Okay, the correct answer is C. For bicarbonate, there are 2. For oxalate, there's only 1. We all know oxalate is this stuff, right? So there are multiple resonance structures, so which means all of the CO bonds are the same, with an average bond order of 1.5. And for the bicarbonate, it's supposed to be like this. But think about there's the resonance, right? To switch the double bond and single bond, which means these 2 CO bonds will have the same length with a bond order of 1.5, slightly shorter. This one is a single bond, so it's a second type of length, which will be slightly longer. Make sense to you? Oh, CC bond. There's no. Oh, I'm sorry. I made a mistake. I should say CO bond, not CC bond. I'm so sorry. So probably some of you choose C, not because you recognize the resonance structure. It's just because there's only one CC bond. But there are so many of you choose D. So probably you also understand the question as I did. Very interesting. Okay, never mind. My bad. Let's try this one. Oh, it seems like it's too easy. But sometimes in the USNCO, if you check the percent of correction or the correct percentage of each question, typically the one with the lowest percentage is not the most difficult. It's the trickiest. Here is the same. So most of you guys chose the wrong answer, C. The correct answer is D. Why? Yes, exactly. Right? The hydrogen on the master group can also be brominated, right? Just under different condition. So if you use Lewis acid, catalyze the reaction between toluene with Br2, you will have the ortho, the meta, the para. But if you use light, H nu, to make this reaction happen, it will substitute the H on the CH3 group, right? So you got 4 different products. Okay. Before you choose the answer of this question, think about, okay? Mm-hmm. Are you familiar with the word distinct? This is exactly the hint the UNCO used to tell you need to pay attention to stereoisomers. Okay, so let's stop here. So the correct answer is D. Probably you will think this position will not be substituted, right? Yeah, it's relatively unstable compared to the allelic position, but it is existed, right? And those kind of hydrogens will be much harder to be substituted on the light because those hydrogens are those carbons are sp2 hybridized, so the CH bond is much stronger, right? And then 1, 2, 3, but number 1 is chiral, right? Number 1 is chiral, so there are 4 substituents. Make sense? I think probably you remember this question, but I slightly revised the question, so pay attention to the words. We probably will end at 10 o'clock, okay? If you need to leave the meeting, just, feel free to leave. So this is a question related to acid-base extraction. So the main goal is use the acid-base properties of the organic compounds and changing their solubilities by converting them into the conjugate acid or the conjugate base, right? Okay. Oh, interesting. We have some more left. Okay. The answer is B. You cannot choose C because C will also deprotonate the phenol, which means you still cannot, separate the two parts, the two products, right? Because both are more soluble in the aqueous solution. You cannot choose sodium carbonate because sodium carbonate is basic enough to deprotonate the phenol, as we mentioned. The phenol has a pK of 10, and then this one is corresponding to the pK2 of carbonic acid, which is around 11. So which means the phenol is strong enough to protonate the carbonate and change the carbonate into bicarbonate, and then itself will be deprotonated, turned into the phenolate, right? And then you still cannot, separate them. Let's have a look at this one. Okay, we pretty much get all of your answers. The correct answer is B. 2 chiral molecules, this one and this one, right? The first one is an A chiral. The second one, you can find a mirror plane in the molecule, right? So it's also A chiral. So there are only 2 chiral molecules. Let's try. I'm not sure whether this one is too hard or not. Okay. The correct answer is C. All of those nitrogens are sp2 hybridized due to the conjugation, right? The left one is aromatic, so we need to make all of the nitrogens sp2 hybridized, right? To have the unhybridized p orbital to be perpendicular to the plane. And those 3, as you know, conjugation will make some of the nitrogens rehybridize. So according to VSEPR, right, those 2 hydrogens are supposed to be sp3 because there are 4 electron domains. But because there is a conjugation system here, so all of them are sp2. So only this nitrogen is sp1. Make sense? Is someone disconnected? This question, I believe, is from the Klein textbook. I believe you all remember, the typical question in the USNCO, asking whether those 4 hydrogens are on the same plane or not, right? A few seconds. Okay. It is a little bit surprising. The correct answer is B. Why not C? Some of you choose none. I didn't quite understand this. Think about 4 carbons, 3 double bonds. So it will be like this, right? So the double bond between the first 2 carbons are here. The double bond between the last 2 carbons are here. The double bonds between the central 2 carbons are here, right? So if we're asking the conjugation, which is here, right? So there are 2 pi bonds conjugated with each other. Make sense? This one probably. Let's try a isomorph counting question. I'll be right back. Okay. I think the answer is C, right? As I shown here. So we have two skeletal structures for the 4 carbons, either a chain or a chain with a branch, right? Left side and the right side. So if you fix the position or location of the chlorine, and then you can move the bromine in different places. So it's 1, 2, 3, 4. They are all different. And then you fix the chlorine on the 2nd carbon, and then you can move the bromine on different carbons. And then none of them will be the same as the previous 4. So you have 5, 6, 7, 8, right? And then for this one, you first put the chlorine here, and then bromine can be here, here, here. These 2 are the same, right? These 2 are the same because they are symmetric if we do not consider any stereochemistry, right? And then you have 3 here. Finally, you have 1 here because those 3 carbons are symmetric right now. So it's 4 plus 4 plus 3 plus 1. Do you have any different opinion? Okay. This is another favorite question. Okay, I'm supposing you all have a, so the answer is C. Obviously, this carbon is sp3 hybridized, which means those 4 carbons can never be on the same plane, right? A few of you choose A. A is correct because the formula is C5H8. The cyclopentene is pentene, right? So it's also C5H8, so it's correct. A few of you choose B, dichloride. Think about if you fix the chlorine here, so another chlorine can either be here, here, or here. So at least there are 3, dichlorides, right? D is also correct because the 3-membered ring, as you know, is very unstable, so it's easy to open the ring, right? Hydrogenation to get the propane. So you need to have 2 moles. I think probably you recall the question in the USNCO Local 2020. I think it's the last question in the Local 2020, right? Asking to explain why the unsaturated fatty acid has a lower melting point than the saturated one. Okay. Yeah, most students choose D. D is correct. More double bond, which means the carbon chain will be more zigzag, right? More, unregular, which will make the distance of 2 adjacent chains further away, and then make the intermolecular forces smaller, right? So then it has a lower melting point. We have a few minutes. Let me show a few more. Maybe, let me see. Yeah, maybe one more interesting question with you. And then we will end the session today. I should say C should be equal to 3.77. It's not negative 3.77. Aditya is asking the sp3 Think about the methane, right? You have essential carbon here. Can those 4 hydrogens on the same plane? No way, right? Okay. More students choose B. B is the correct answer because the Z, isomer is more stable, and then the E isomer is less stable. And after the deprotonation, there is no difference in between the Z and the E, right? So which means the more stable one will be easier to lose the hydrogen, so it will be more acidic, and then the pK will be smaller. Make sense? Okay, guys. Now stop here. So it's my pleasure, to share some questions, made by me, or some of them are revised by me with you guys. We have a few minutes. I hope you enjoyed the practice with me. And do you have any last minute question? If no,
For the somebody else for the part 1, what do you think a good score would be to like, or like a safe score to ensure to be in the top for the part 2?
Okay. As I know, first it varies, year by year, but in the recent few years, I would like to say 43 plus will be safe. If we assume the difficulty is pretty much the same as 2019. But my prediction is probably the test will be slightly harder than 2019 National Part 1. So, just to share some, my personal observation about cutoff. Last year is 40. I'm very, sure about this. The year before last year, and including, 2 years ago, they are both 42. So this is why I said 43 plus should be a safe score, but it really depends. And this year, everything can be different due to the online exam. You're right. This question, the answer is B. Thanks for working on this. Okay, if we do not have any further question, so I hope you all enjoyed the practice and wish you the best. And feel free to discuss with me in Discord. Have a good night, guys. Bye-bye.
Thank you.
No problem. Yeah, I will, send the recorded video, and I will also revise, my questions and share with you guys later in Discord and also in my personal website. So check them. We have at least 1/3 of the question we didn't finish. So you guys can, take some time to work on it. And I will also share the answer key with you. But not all of the questions are very good. So, judge it by yourself, okay? Bye-bye.